In today's lecture, I'm going to cover section 2.1 from the textbook. And in this section or in this lecture, we are going to learn how to draw or curve the solution without finding the solution of the differential equation. Let me, before do some revision about what we studied from the beginning of the course. Actually, we studied the differential equation and the initial value problem and the solution of the differential equation and how to solve some specific kinds of first order differential equations. If you remember, the first kind was a separable differential equation, and the separable differential equation has the form dy over dx equal gx times hy. Gx times hy. And to solve this equation, we will separate all x together and all y together, the dx with all x and the dy with all y, then integrate both sides to get the solution. Then we move to second kind of the differential equation in our course, which was the first order linear differential equation. Let me write first order linear differential equation with the form y prime plus bxy equal f of x. And to solve this equation, I think all of you know, you should find the mu of x, and also you have to multiply your mu, times y equal to your to the integral of mu times f. Okay. Then we move to the third kind, which is an exact differential equation. Exact differential equation has the following form: m times dx plus n times dy equals 0. And to check if this equation is exact or no, I have to find partial n by partial y and check if it is equal to partial n by partial x. If those two quantities are equal, then I can say my equation is exact. Then I can let my function f with partial derivative with respect to x equal to m, and I will integrate both sides. Then I will find g. If you remember the steps, here g and here the integral. And last step is to write your fxy equals c. So 5 steps, you have to write them in your cheat sheet. I'm sorry if I didn't tell you that you must start preparing your cheat sheet from now. And by the way, the good students usually start preparing the cheat sheet from the first lecture of the course. Now, fourth kind, actually in the fourth kind of the differential equation, we use some appropriate substitutions. We have three kinds of substitutions. The first kind, which is u equal y over x. And I can use this substitution to solve two different kinds of differential equation. The first one, which y prime equal f of y over x. And the second kind, the homogeneous equation with a specific degree. And there is an equivalent between those two kinds. But maybe you can depend on this to suppose this, or homogeneous, which depend on the t. So this is the first substitution. The second substitution is to let u equal a linear expression. So it is ax plus by plus c. And I usually use this substitution when the differential equation has the following form: f of ax plus by plus c. Last substitution, which can solve the Bernoulli differential equation, has the following form. You have to choose your u to be y to the power 1 minus n, such that the form of the differential equation is very close to the first order linear differential equation. But the right hand side, notice now that your right hand side, it is f of x times y to the power n. So to solve this equation, which is non-linear, and we call it Bernoulli, I'm going to use the third kind of the substitutions. Okay. Now, what I want to tell you is that sometimes after solving the differential equation, maybe we'll get the solution y equal x squared plus sine x. Maybe this is my solution plus c, maybe. And sometimes also my solution, it is y equal x plus 4. So that depends on my problem. Now, my question, can I draw this function? Can I draw the curve of this function? What do you think? What about of this function? Do you know that this equation represents what?
This is a linear function.
Yeah. So if I want to draw the graph of this linear function, it will be what?
It will be a
So
straight line.
A straight line. Great. So usually, if I have a linear equation, so if I try to curve it, I will draw a straight line. Notice here only x and y without any power. Okay. Now that if I solve the equations, then I can draw the solution depending on the equation. So if my equation, if my solution, sorry, it is y equal x squared. What do you think about the curve here? What do you think about this curve? Y equal x squared.
A parabola.
Yes, it's parabola. So if you solved the equation, after solving the equation and finding the function, you can draw it. In today's lecture, actually, we are going to draw the curve of the solution without solving the differential equation. So our aim of this lecture is to draw the curve of the solution of any differential equation without solving it, without solving the differential equation. To do that, you need to remember the concept of slope and tangent and slope field and the isoclines and how to draw straight line, how to draw parabola and circle. Let me now start by the new ideas of our today lecture. This is the objective. And let me here do some revision about slope of lines. So now I'm not sure if I should write here. Yes, let me try to save them. Yes, using this color. Yes. Let me ask you about the following line now. If I have y equal 2x plus 1, I think it isn't necessary. Just give me 1 minute. No need to write using the PowerPoint pen. I'm going to use the zoom pen now. Yes. What about if this line y equal 2x plus 4? Could you please tell me the slope of this straight line? Do you know the slope is what? 2, the coefficients of x. So here the m is 2. The slope is 2. What about of this y equal negative x plus 1? So the slope here is what?
-1.
Negative 1 plus 3. So the slope is negative. Always the slope is negative. Is the coefficients of x. Now let us try check how to draw the straight line if the slope positive and if the slope is negative. So here my y-axis and here my x-axis. My x-axis. Now let me ask you about the line y equal x. Do you know this line? Do you know this line? It's a famous line. What do you think about y equal x?
It's a line with a 45-degree
Yes,
x
great.
y.
Yeah, who is speaking?
Basil.
Basil, great Basil. So this line is the bisector of the first quadrant and the third quadrant. So the angle between it and the x-axis is 45. Great. So to draw it, it's like this. This angle is 45. Okay. Notice now this line has a slope 1. And I know all the lines who parallel to this have the same slope. So now this line here, this line parallel to this. So also here the m is 1. Also here, this line is parallel to this. So the slope also is 1. So all the lines parallel to the bisector of first line has slope 1. Okay. So the line, the small line segment, this one has slope 1. The line segment here also has slope 1. The line segment here also has slope 1. Now, let me ask you if the line has this equation y equal 2x plus 4. So now the slope is 2. Only I need to check if the slope is 2. So the line must be more horizontal than this or more vertical than this? What do you think?
More vertical.
Yes, great. So if the slope is 2, let me use the red. If the slope is 2, so the line will be like this. More vertical than those with the slope 1. So the red had the slope 2. Let me check now using the green if the y equal half x minus 7. So the slope here is half. And at that time, this line must be more horizontal. So it will be like this, maybe. Like this. Like this. So all the green with the slope half. Don't forget also, you can draw a small line segment parallel to this line such that its slope only also half. So this has a slope half. This has slope half. Okay? Did you get the idea of positive slope? Now let me go to the negative slope. So here the y-axis and here the x-axis. I'm sorry for my drawing now. This is y and this is x, but I need to, yeah. Now let me start with this line, or y equal negative x. What do you think about this line? It is what? Y equal negative x. Speak,
The
please.
bisector to the second and fourth
Yes,
quadrant.
the bisector of the second and fourth quadrant. You are right. So it will be like this. And this angle, it will be 135. So here 90 and here 45, so 135. So this line has a slope -1. Also, this line has a slope -1, and this has a slope, and this line segment also, and this line segment also, and this line segment. Okay. So now what I need you to understand how to draw line segment with a slope -1, with a slope -1, with a slope -1. What about if the equation was y equal -2x plus 4? So here -2x. So it will be more vertical. So this line or this line parallel to it, or this line parallel, all the blue are parallel, and I'm sorry for my drawing. So this has the slope -2. What about using the white now? What about of the y equal -half x plus 7 maybe? It will be more horizontal. So it will be like this maybe. It will be like this. It will be like this. And this line segment with the slope -half, and this line segment with the slope -half. You have to write or draw those slopes on your cheat sheet, such that if you have in your exam m equal -1/4, so you should to know that to draw this one, it must be like this. Like this. It isn't like this. It isn't at all like this. It isn't like this. It must be like this. Similar to those. Okay? I think most of you know those slopes. Now, also what I need you to understand. I'm sorry. Yes. The horizontal line. So the horizontal line is what? The horizontal line is what? Do you know how to draw a horizontal line?
Y equals 0.
You are right. Y equals 0. You are right. Y equals 0. It is the x-axis. So this axis has equation y equals 0. Okay. And now my question, not only the x-axis, all the horizontal lines like this. This is horizontal line.
equals
This
C.
is, yes. This is, you are right. Y equals C. You are right. Y equals C. All of them have the slope 0. What about of the vertical lines? Vertical lines. Those lines who has infinite slope like this. Infinite slope. So all those
X
lines,
equals C.
x equals C. You are right. X equals C. Now what I need you to understand that this line segment, 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 هذا slope equals 0. And this line segment, this line segment, this line segment, هذا slope equal infinite. Okay? Also, what I need you to remember, I think all of you know those ideas. How to draw a circle and how to draw parabola. Don't forget that you have four kinds of parabola. Maybe your parabola will be up. Do you remember that? Or maybe it will be to the left or to the right or down. That depend on the equation of the parabola. And now we are going to deal with some of them. Is it clear? Yeah. Also, what I need you to remember that the curves of two different solutions can't cross each other and can't be tangent to each other. What I mean by tangent, so they have only one common point, okay? So if you have two solutions, after solving the differential equation, so you have differential equation and you solved it, and you try to draw your solutions depending on the constant c. So I have my c1 and your c is 2 and you 3. So we have more than one solution depending on the value of c. If we try to draw all those solutions, no common points between any two solutions. Any two solutions can't cross each other and also can't be tangent to each other at all. And that depends on the existence and uniqueness theorem. Now, maybe now you have a new words. I wrote here, if the isocline and the slope are identical, then they are represent a solution curve. What about the word slope? Yes, I know the word slope. It's very easy for me, the word slope. I know that if each line has a specific slope. What do you mean, Professor, by the isocline word? It's a new, I think. I'm going to explain in the coming slide. But now, what I need you to understand, if you try to solve a problem depending in our lecture today, and you have, in a specific example, that the isocline and the slope are identical. So you have to say immediately that this isocline is a solution for the differential equation. So the isocline, it is a curve. Okay, and look how we can draw it now as the following. First of all, let me introduce the definition of the slope field. I have this differential equation. Let me ask you also another question. Now, if I have the following function, y equal sine x, say it is sine x, and I asked you to draw its tangent at the point maybe 1, 4. So can anyone of you help me how to do that? Or could you please tell me the first step which I have to do? So I will repeat my question. I have this function and I need you to find the equation of its tangent at this point. Do you remember the first step?
Doctor, a question.
Yes, ask.
Does y and 4 even like satisfy the equation?
I'm sorry. No, it must. It must. So let me choose 0 and 0. Actually, I choose them randomly, but you are right. It must satisfy the equation. So let me choose 0 and 0. I'm sorry. Thank you. Who is speaking now?
Basil.
Basil. Great, Basil. Excellent. So starting from the coming lecture, I'm going to buy a box of chocolate, and those who will participate in a good way, they will receive a chocolate, inshallah. Okay? Now, let us go back to this function. Anyone, if you remember the first step to find the equation of the tangent?
Differentiation.
Yes, differentiation. Why do you want me to find the first derivative? Why do you want me to find the first derivative? Why?
Because it's the slope.
You are right. Great. So starting from now, all of you remember, to find the slope of any tangent, you have to find the first derivative. And the y prime is my slope. Don't forget that y prime, it is dy over dx. So dy over dx, it's my slope at this point or at the given point. And I can say also that my fxy, it is the slope of the tangent at the point xy. So f(1,7) equal m, it is the slope of the tangent of the given function, not this one, at the point 1,7. Okay, so starting from now, fxy, it is my slope because it is my y prime, and the y prime, it's the slope. Now, what I want to say also, that here to draw the slope fields. So notice now, let me go back here. I have here the y-axis and the x-axis. And I'm going now to explain what I mean by slope fields. You have here in this plane a lot of points. You have here point. You have a lot of points here, yes? For your function f. The word slope field, that means in each point here, you have to draw small line segment with a specific slope, coming from this. So from this end. So for this point, I'm going to substitute x and y in my f. Okay, so I will receive the m. So in this point, I'm going to draw line segment with the slope m. So maybe like this. In this point, the slope is like this. In this point, the line segment has the slope equal 0. In this point, like this. In this point, it is 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 like this. In its point, yeah. You have to draw in all points some line segments with a specific slope. From where I can get the slope for each point from the function f. I call those line segments, which I draw usually, linear element. And that for each point from your plane. Okay? And now this slope field will help me to draw the solution of the differential equation without solving it. Actually, this technique is very useful sometimes because you have complicated equation and you can't solve it. But by the way, don't use this method unless if I ask you to do that. Okay? But after you graduate, maybe in your work, maybe you will find a differential equation and you can't solve it. And you need approximately curve to the solution. So you can follow this method. Okay? But please don't use this method unless if I ask you to do in the exam. Now, let me also go to the word isocline. Till now, I didn't explain what I mean by the word isocline. Now, I have this differential equation and I need to draw the slope field. What I mean by the slope field for a differential equation, that means in each point, you have to draw line segment with a specific slope. Okay? Now, because I don't need you to draw the line segment randomly like this here and here and here and here and here and here. No, I need you to draw some suitable line segments. Those line segments, to be more useful for me, I'm going to draw them on the isoclines. And Professor, till now you didn't tell us what do you mean by isocline. The isocline is a curve which you can find its equation by let your right hand side equal constant. So to find the isocline for any differential equation, take the right hand side and let it equal to a constant. And depending on the value of this constants, you can draw more than one isocline, as I'm going to do now. All those in introduction to what I need to explain, and you can't understand if I didn't solve a specific example. Let me read the problem now and simplify it and solve question by question. So here, first of all, he need me to draw isocline and slope field. So this is the first equation. I have differential equation, and he asked me to draw isocline and slope field. Second question, how do the solution through the following points, 1 point, second point, third point, will be. So he need me to draw the solution of this given differential equation without solving it, but depending on the isocline and slope. And I'm going to explain in details. Second question in this problem is, if y of 0 equals 0, that means your x is 0 and your y is 0, then estimate the y of negative 100. Let us together study this problem and let me explain in details how to do it. Actually, absolutely, in exam 1, you will find one problem similar to this, at least 15 marks. Okay, so focus please, it's very important. So my equation is y prime equal x plus y squared, x plus y squared. So here, let me use the PowerPoint bin now. So my equation, it is y prime equal x plus y squared. And I asked you now to draw the isocline and the slope field. Okay, this is the first question. So here, first question, to draw the isocline and the slope field. Don't forget that this is your f. This is your f, okay? Now, to draw the isoclines, you have to take your f and let it equal to c. So x plus y squared equals c. So the isoclines are some curves come from this equation. So I'm going now to draw the curve of this equation. But notice now, you have parameter c, and you don't know the value of c, so you can't draw the curve. To simplify the problem, I'm going to choose some specific simple values for c. So let me, first of all, choose my c to be 0, maybe. And let me call this equation star. So equation star, it will be x plus y squared equals 0. And that will give me my y squared equal negative x. Do you remember y squared equal x? This is an equation of what? Yeah, what do you think? Do you remember? Y squared equal x. Speak please.
The parabola to the left.
Yes, it's parabola to the left. Great. Let me draw here the y-axis. I'm sorry, but the PowerPoint doesn't have a ruler. This is x-axis and this is y-axis. Okay. And I'm going to draw this parabola, as your colleague said, it's to the left. Actually, for me to draw any parabola, I need at least 3 helping points. So I'm going to take here 3 helping points. If the x and y. If I choose my x to be 0, can anyone of you tell me the y? If the x is 0. And you choose
0.
Yes, also it's 0. Now let me choose my x to be 1. If your x is 1, what do you think about your y?
It can't be on.
It can't. Great, it can't. So what should I use? Let me choose my x to be negative 1. So now I have negative 1, which is 1. If your y squared equal 1, so your y is what?
Positive 1.
Yes, positive or negative 1. So here, positive 1 or negative 1. So now I have 3 points for my parabola. First one, 0, 0. So here, the first point. Second point, -1 at x, -1 at x, and 1 at y. So -1 here and 1 here. So this is my second point. Third point, -x, -y at 1. So here, this is the third point. So my parabola, as your colleague said, it's go to the left. And here, also from down, go to the left. This is the first parabola come from C equals 0. Sorry, this is the first isocline come from the C equals 0. Now you have to choose second C. C equal any number you need, but please choose simple number. So I'm going to choose it to be 1. Before that, before you go to the second C, you have to draw on this isocline the slope field. What I mean by slope field, some small line segment with a slope field with the slope equal 0. So always this C also represent the slope of the line segment on this isocline. So let us together draw on this isocline small line segments with the slope 0. What do you think if your slope is 0? So the line segment must be like what?
Horizontal.
Horizontal, parallel to x-axis. So on this yellow, I'm going to draw small line segment parallel to x-axis. On all it, okay? All those blue on the first isocline has a slope 0, so they are parallel to x-axis. Let us go back to the second C using the yellow. So in star also, focus with me please. It's x plus y squared equal 1. That will give me my y squared equal 1 minus x. Also, it's a parabola. To draw it, I need also some helping points. I'm going to draw them here. I'm sorry to write here. Actually, because my board is small. So here x and here y. Now, let me choose my x to be 0 if your x is 0. So your y squared is 1. Focus, please. Y squared is 1. If the y squared is 1, that means y is what? Y squared 1. So y it is 1 or -1 for x 0. Now I need a extra point. Can I choose my y to be 0? Let me check. If the y is 0, move -x, so the x is 1. So I have 3 points. The first one, 0x, 1y. 0x, 1y, it's here. Second point, 0x, -1y, it's here. Third point, 1x, 0y, it's here. So it's a parabola, but it is shifting 1 to the left, to the right, sorry. So this is my parabola. And this parabola come from C equal 1. On this parabola, you need to draw slope field, which is small line segment with specific slope. The slope now is 1. So the C is a constant and it's the slope. Now I need to draw on the new isocline the line segment with the slope 1. So the line segment with the slope 1 is like what? Slope 1.
Y equals x.
Y equal x. It's a bisector for the first quadrant, so it will be like this. 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 Like this. and so on. Okay, all of them are parallel, and each one of them has slope equal 1, and so on. Let me go to the third C now. Professor, how many C do I need? You need at least 5. And maybe in the problem of our worksheet, you need at least 7. And the values of C, there is actually, sometimes you should use a specific C, and sometimes you are free. Okay? Now I can't tell you until I solve maybe 2 or 3 problems. So now my third C, I'm going to choose it to be -1. That will give me an equation star x plus y squared equal -1. And that will give me the y squared, it is -1 negative x squared. I need a table here to draw the curve. X, Y. Focus, please. And I hope you try to do this table by hand. If you didn't do by hand, you can't do it in the exam. Okay? So now, let me choose my x0. If the x is 0, so the y squared is -1, you can't. So let me choose my, here y, it is squared. Who wrote here x squared? Who? It isn't x squared, it is x. Am I right? Focus, please. Yeah. So let us continue now. I need the pen. Yes. Now I can't choose my x to be 0. Let me check if my y can be 0. If the y is 0, so move negative x, it will be x equal -1. So y 0, x -1. I need other three points now also. 2 points. Yeah. What do you think about this x? What do you think? Yeah. Can anyone help? I need helping points.
-2.
-2. So let me choose the x to be -2. So y squared equal -1 plus 2. Because you choose negative and negative, which is 1. So y squared, it is 1. So the y is 1 and -1 when the x is -2. So I have 3 points now. Let me try to draw. The first point, 0y, -1x, it is here. Now, -2x, here -2x, and the y, it is 1 and -1. So it will be here point, and here also point. So that's my curve now. My third isocline is like this. Like this. I'm sorry. On the new, so let me write here that this isocline comes from C -1. And on this new isocline, I'm going to draw the slope field, which is small line segment with a specific slope. And this slope is, it is now -1. This is my M equal -1. M equal -1 is the bisector of the third quadrant. So it will be like this. Bisector of the third quadrant, it will be like this. I always advise the students when try to solve problems like this to use a big scale, okay? To make it easier to be understand. Now, let me go back to my C's. I'm going to choose my C now to be, so fourth C is C equal 2. That will give me an equation star x plus y squared equal 2, and that means my y squared equal 2 minus x. And to draw it, I'm going to choose the table here. I'm sorry, because I don't have space. So x, y. Now, can I take my x to be 0? If I choose my x to be 0, so the y is what? If your x is 0, y is what?
Also negative square root of 2.
You are right. Positive or negative root 2. Positive or negative root 2. Now also, maybe let me choose the y to be 0. So the x is 2. So the y is 0. If your y is 0, move the negative x, so your x is 2. So the first point, 0 at y, 2 at x, so it is here. Second point, 0x, root 2 of y. Root 2 of y here, root 2 at the y-axis, it will be up number 1 or down number 1? What do you think? Root 2, greater or smaller than number 1?
Great.
Greater. So it will be here maybe. And negative root 2 here. Now my new isocline, it's also parabola. Go from those points. And also if from down, similar to this. So this don't forget, this come from 2. On this isocline, I need to draw slope field, which is the line segment with a slope 2. So my M is 2 now. Yeah, the M is 2 is more vertical than M1 or more horizontal? I forget. What do you think?
More vertical.
More vertical, so it will be like this maybe. Like this, like this, like this. It isn't parallel to y-axis, but it is more vertical than this, more vertical than the one, more vertical than the one, more vertical than the one. I know you need to practice how to draw those, but I think it's easy. And if you make your scale bigger and bigger, so that your drawing will be more clearer. Okay. Last C now. Last C, and by finding the last C, I will get the solution of the first question of this problem. Now my C, let my C to be -2. That in equation star will give me x plus y squared equal -2, and that will help to write y squared equal -2 negative x. And let me check the table. X and y. Can I choose my x to be 0? No, because the y squared is -2, so I can't choose my x to be 0. Let me check if y is 0. So my y is 0. So the x, so if I move this here, so it will be x equal -2. This is the first point. Let me choose the x to be -3. So if x -3, so it will be y squared equal -2 plus 3, which is 1. So the y, it's positive -1. So -3 and -3 will give me 1 and -1. So I have the first point, -2x 0y, it's here. Second point, -3x here with y1 and -1. So it's here and here. So my last isocline now is also parabola. Don't forget that this comes from C equal -2. On this isocline, you need to draw the slope field with line segment of -2 slope. And -2 slope is more vertical than this. More vertical than this, so it will be like this. 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 It isn't parallel to y-axis, but it is more vertical than this. More vertical than this. More vertical than this. Okay? Any question about how to draw the isoclines and how to draw the slope fields? I think it's easy. Let me go to the second question. Second question, he asked me, how do solutions through the following points behave as x tends to infinity and x tends to the negative infinity? Let me take the first point. So now I need, look here, you didn't draw the solution of the differential equation till now. You only graph the isoclines and the slope field. Now I'm going to draw the first solution of the differential equation, which go from the point 0, 0. So I need you to draw the solution of the given differential equation without solving it, and that solution go from the point 0, 0 here. Now, let me ask you a question. I have, but I'm going to use this one just 1 minute. So if you have point here, and look to the blue line here. Here, the line segment, this one, this line segment, I'm going to draw it here. The white point is my point in my solution, 1 point of my solution. And the blue line segment, it's the tangent of my solution at this point. Now, I'm going to draw my solution, and please tell me right or wrong. Maybe I'm going to, where is the pen? Yeah. So maybe I'm going to draw my solution. Now it's a curve like this. Can we accept this solution, go from this point and this line segment to be its tangent, or we can't accept it?
No, we can't.
We can't, because this line segment across this curve, it isn't tangent. So this one is wrong. What do you think also about this? Also wrong. Now, what do you think about this one? I think we can accept this. Also, what do you think if my solution down? Also, we can accept. So, I'm going to draw maybe like this or maybe like this. I'm not sure. Let us together. Let me check this one first. So here at this point, this is my curve. So I'm going to do that like this. Unfortunately now, notice if you go down, so you will cross this, and you can't cross any line segment. So you can't go down. Let me check, can I go up? And I'm going to use just 1 minute. I'm sorry, I have to go between those 2 pens to make the lecture clear. Yes. So now we decide it must be up. Let me check. Can I go up without crossing the line segments? Only to be those to use those line segment as a tangent. Notice from here, nice. Notice from here also, great. I will go up and we will go up. Great, great. Let me check here. Can I go up? Can I go up like this? Can I go up like this? Or no? What do you think? Can we go up?
No, we can't.
No, because here you have line segments. So, Professor, what should we do? Look what we are going to do now. I'm going to graph the solution between those. I can't cross any line segment. I can't cross any line segments. Is it clear? This is the first solution. Go from the point 0, 0. So this is the first solution for the differential equation. Now, also he asked me to graph the solution with go from the point, let me use the red, from the point 0, 1. Where is the point 0, 1? Here. This is the point 0, 1. Actually, I feel here is the line segment. Here is the line segment, and I have to go up. That depending on my line segments, can I go down? By the way, as I told you, you can't draw any 2 solutions that's such that there is any common point between them. So now I can't cross the white. I can't cross the white. So I have to go near it. Near it. Maybe it's asymptote to each other. This is the second solution. Now let me choose which color now should I use. Which color? Let me use the green. I'm not sure if you can see it. So the second point is 0, -1. 0, -1, it's here. It's here. Yeah. Can I go up here? No, I can't. Yeah, actually, for me, I think it's easy to draw like this. But what should I do to continue my solution? I have to go down, such that this line segment, it is a tangent of my line, of my solution. What do you think about the curves of the solution? I draw here three different solutions: the green, the white, the red. What about the yellow? The yellow, those aren't my solutions. Those are isocline, and I draw them to help me to draw the slope field, which is the blue line segments. We finished the second question of our problem. Let us read the third. Yes, do you have a question?
Doctor, I have a question.
Yes, ask Muhammad.
The green line, couldn't it continue, like parallel to the other solutions, like to the left upwards?
Yeah, so do you want me, look, I understand you, and I'm going to draw, and you have to tell me right or wrong. You need me to go from here up. Am I right?
Yeah,
Like this?
no, like horizontal, like
Like
to the
this?
yes, upwards, but parallel to the blue lines.
So parallel to the blue lines, to this one, to this
Yes.
one. Yes, I understand you, but let me just 1 minute. Unfortunately, I used the. Just give me 1 minute. Yes. So do you know? Do you need to draw anything, Muhammad?
Yes. Can it go like this?
Yes. Use your pen.
Oh.
No, I can't see. Yeah. Yes, I understand. So you need to take yeah. Please clean what you draw now, Muhammad.
Okay. I'm not.
You can't. Yeah, I can do. Yes.
Yes.
So you want me to draw it like this? Am I right?
Yes.
Like this, and then
Yes.
it will be how? After that, you have to continue and go to negative infinity. Then you want to go up. Actually, the problem, Muhammad, it's here because this one it is your slope. The idea here, Muhammad, I have extra line segments will be here between those two. So if I draw other isocline here between them, okay, and I have here extra line segment, so you can't cross it. So if you try to draw it like this, so it will be crossing to this line segment. So I
Okay.
can't do that. Actually, I know, sometimes it isn't clear. But to understand more and more, you have to choose a big scale. And at that time, you can decide, no, I can't go from this point, and I shouldn't go from this side. Yes, Abdurrahman.
Yes, doctor. Is there more than one correct solution, or is it only one?
No, only the look to the white one. Only one white. Look to the red. Only one red.
Because I mean, for the green doctor, it could have been went to the left and down.
No,
you did it in
no, only this one. To be sure, please choose your C one time to be 2.5 and one time 1.5 and negative 1.5 and negative 2.5. At that time, you can draw more line segments and you can decide, no, I can't go like this. I must go down. But for me, because I need to solve another problem, so no need to choose more than 5 C's in this problem. Actually, in the coming problems, maybe I need more than one C, and I will tell you when you should use more than 5 C's. Okay? Other questions, or can I solve the third question of this problem? No questions? So let me solve the last question of this problem. Last question, he asked me, if y of 0 equals 0, then estimate the y of negative 100. Okay, let me use, yes, which color now? Let me use the white, no problem. Where is the white? Yes. So here now, he need if y of 0 equals 0, then find y of the negative 100. It's equal to what? By the way, this is your x and this is your y. Now, if your x and y are zeros, so you are in this point. Okay? And in this point, your solution is the white curve. So you are now in the white curve. Did you get the idea why I'm now in the white curve? Because my x is 0 and y is 0, so my point is 0, 0, and from 0, 0, I drawn here the white curve. Now, the x, which I need to be negative 100, so my x, it's here, here, here. The negative 100 is far away to the left-hand side. So my curve, notice my curve now, my curve is go like this, okay? I don't know my curve, but what I know, look what I know now, that my curve and this, the isocline, the isocline also will be like this. So I noticed that at 100, at negative 100, my curve is very close to the isocline, this one. So those two, the white, my curve, and the yellow, this one, which is the isocline, as those are very close. So at negative 100, my y is similar to the y of this curve. So y. So now I'm going to choose when c equals 0, nothing here, c equals 0, that will give me, where is the c equals 0? It's here, and the curve is like this. So x plus y squared equals 0, such that my x is negative 100. That will give me negative 100 plus y squared equals 0. I'm going to move negative 100, so y squared equal 100. So the y has two different values, maybe only 10 or maybe negative 10. Which one is suitable for my curve, my white curve? Which one should I use? The positive one. And this one can't, because my white curve is up to x-axis, so all its y, all its value must be positive. Is it clear? So do you have any question about it?
Doctor,
Yes.
why can't we take the isocline that is below it?
No, could you please repeat it? Yes, I understand. You are right. Who is speaking?
Mahmoud.
Mahmoud, great. Let me check if I choose the second, the below one. So here, using the y or using this color, look, I'm going to use this color. And you asked me that this isocline also, this one, will be very close to this, will be very close. Okay, so let me choose this instead of this. And this isocline come from c equal negative 1, am I right? So c equal negative 1, so this is my equation. Let me plug in my equation here. I'm sorry, because I don't have space, and I'm going to clean those. So x plus y squared equal negative 1. My x is negative 100, so negative 100 plus y squared equal negative 1. So my y squared equal 99. Am I right? Because I moved the 100. So the y, it's square root of 99 positive and negative, which approximately positive and negative, approximately. This is the sign of the approximation. It's positive and negative 10. So the root of 99 also is approximately. And by the way, I'm so sorry, I should write here approximately, because I go up and you can go down. One of them or both of them are approximately solution, not the exact solution. Great, Mahmoud, also. Okay, maybe I need to buy more than 10 boxes of chocolate. Is it clear now? I'm going to clean those, and only you need to write in your exam those steps. Can I move to the second problem? It's similar to this, but with a new differential equation. So let me go now to the second problem. By the way, here you will find site online site. In this site you can check your solution, so you can use some functions and the program here or the code will show you the solutions. Isn't important for me. Now please type your name on chat. All of you, please write your names. And unfortunately, only 16 students, and I notice in Blackboard I have 24 students. So 8 students are absent today. I have to check why. Starting from the coming lecture. Yeah, so let us continue. Now I have the second example here. Also the same. You need to draw isocline, slope field, solutions for specific points, and estimate something. Let me write here my equation. Y, so it is y prime. Sorry, y prime equal y times 2 minus y. This is my equation. To solve this problem and draw the isoclines and the slope field, first step is to find the equation of isocline, which is y times 2 minus y equals 0. Equals C. I'm so sorry. This is the equation of all isoclines. First thing, I'm going to choose my C to be 0 to draw the first isocline. That will give me y times 2 minus y equals 0. From this, I can say maybe my y is 0, the first isocline, or my y it's 2. Am I right here? If this product is 0, always if I have any product equal to 0, that means maybe the first one is 0 or the second one is 0. Now let me draw the isoclines. Let me choose the red to draw the y-axis and x-axis. I'm so sorry. Actually, I don't know if anyone of you know how to use a ruler in PowerPoint. Do you know? Anyone of you know? Yes. Actually, I have in Zoom a ruler, but I don't have here in the PowerPoint.
Doctor,
yes.
There's an application called Whiteboard made by Microsoft also.
Yeah.
Has a ruler
Yes.
and more advanced pencil.
Yeah, but actually, because look here, I attached or I added some notes before the lecture to my PowerPoint, so that I'm going to depend on the PowerPoint. Okay,
Yes.
I know the second application. Yes, there is more than one. Oh, by the way, also I can use OneNote, but yes, I will check if I can do, make better than this. and this is my x-axis. Y. Now let me draw the two isoclines come from C0. First isocline has an equation y equals 0. Y equals 0 is what? Do you know?
The x-axis.
The x-axis. So here the first isocline. Second isocline, y equal 2. Also, it's parallel to x-axis. So this is my second isocline. Those two isoclines come from C equals 0. C equals 0. On both of them, I'm going to draw the slope fields such as I have line segments with the slope equal 0 using the blue to draw the isocline. So here my M is 0. So M0 also parallel to x-axis. So my line segment parallel to x-axis, my line segments. So here my line segments. Okay. Now, if you remember before 2 slides, I wrote if the line segments or those slope field and the isocline are identical, then the curve is solution for my differential equation. Now, so this one and this one, those are solutions for the differential equation. Actually, he didn't ask, but take care about this because the yellow and the blue are identical. So the yellow and the blue at this case are solution for my differential equation. Let us continue and choose another C. So second, yes, let me go to the yellow. So here, second, my C is 1, maybe. That will give me this equation star, let me call it a star in a star in a star, y 2 minus y equal 1. Can anyone help? How to find the y? Can anyone help? How to find y?
We can multiply the y by
Yes.
the bracket.
Yes. Actually, no one can say maybe y is 1 or maybe 2 minus y is 1. That only if it's 0. So now I have 2y minus y squared equal 1. I'm going to move all of them. So I have negative y squared minus 2y, y squared minus 2y plus 1 equals 0. And this, it is an identity. So y minus 1 equals 0. Y minus 1 squared equals 0. So my y, it is what? Help me, please.
It's 1.
It's 1. Now let me draw this isocline using the yellow. Y equal 1. It's a horizontal line parallel to x-axis. Go from y equal 1. This y equal 1. So it must be like this. On this isocline, don't forget to say that it is coming from C equal 1. Now on it, I'm going to draw a slope field with slope field of the line segments with this slope. So M equal 1. Now M equal 1, that means the line segment parallel to the y equal x, the first, the bisector of the first quadrant. So it will be like this. Am I right?
Yes.
Okay, let us go also to the second C. So 3, I'm going to choose my C to be negative 1. So my equation, it will be y 2 minus y equal negative 1, multiply here. So you will get now y squared minus 2y minus 1 equals 0. Please use your calculator to find the solution of this equation. So the y is what? What do you think?
1 plus root 2.
1 point?
2.4 and 1 point.
2.4, 2.4 and
negative 0.4.
negative 0.4. Great. So I have extra 2 isoclines. The first one 2.4. 2.4, it's up here. Okay. So this come from C equal negative 1. And the second one, it's negative 0.4, so it will be down here. So this come from C equal, this come from C equal negative 1. On it, I'm going to draw specific line segments using the blue. With my M now, it is negative 1. So let me do that. Negative 1, it's like this. Negative 1, it's like this. Like this. Like this. Like this. Am I right? Yes? It's parallel to y equal negative x. Now, because I don't have time, maybe I have only 2 minutes, let me draw the solutions, okay? So I'm going to choose the white to draw the solutions. First one, go from which point? So go from point 1, 0, 1. So first solution, 0, 1, because I don't have time. 0, 1, it's here. I need to draw the solution such that this line segment, it's tangent. Okay, can I do the following now? Can I do the following? No, because you cross this. Can I do the following? Look, can I do the following like this? Can I do the following? Can I go up? No, I can't, because also this is solution. So now we are going to draw solution. We can't cross any two solutions. So can I take like this? No, you can't cross the white solution with this one, because yellow and blue are solution. So what should I do? How to draw the solution now, such that this line segment, it's tangent on this point? What do you think? Can I do the following? Look, can I do the following now like this? What do you think about this? Now, my first solution is the white one. I can't cross the yellow blue. I can't cross the yellow blue because those are also solutions. Let me go to the second point, and I'm going to use now maybe the red. The red for the point 0.3. 0.3, no, I'm not going to draw 0.3. I'm going to draw 0, -1, and also 0, -1. Notice now, let us check 0.3. Where is the point 0.3? 0.3, it's here. Okay. Now, actually, you need your point between some isoclines. So you should use C equal 2, and you should use C equal -2 to draw more isoclines. So the secret now, how many isoclines should I draw? That depend on the points which I'm going to give you. So now my point, it's out of the isoclines. I need it to be between some of them, okay? Look what I'm going to, for me, I can guess it will be like this. It will be like this. And also the last one, which is let me use the green now. For the last one, which is 0 and -1. -1, it's here. to draw the solution, it will be like this. Okay. Now he asked me to find if y of 0 equal 1, then estimate y of 100. So now y of 0 equal 1, and I need to find y of 100. Only 1 minute, please. So y of 0, the x is 0 and y is 1. So you are in the white, you are on the white curve. Now, if you are in the white curve like this, so here you will be like, sorry, the white curve here, the white curve. Your x will be on the right. How to find the y? So which curve should we use now? Which yellow curve to estimate y of 100? When c equal what?
C equals 0.
When c equals 0. Notice now, notice that this curve is asymptote, or this straight line is asymptote to this curve. So you can say immediately that those two curves, the straight line and my white curve, have the same y. Or you can say this c is 0, and if the c is 0, you have two different values of y. Which one you need to choose? Don't forget here the origin, here the x-axis. So, and here the y is 2. So I need my y. If c is 0, so my y is approximately 2. What do you think? Is it easy, or what do you think?
Yes.
Yeah. By the way, we are going to meet at 1 o'clock also if you need to do the worksheet together. Let me tell you that I postponed the deadline for the worksheet to be midnight, and also I upload to the Blackboard previous samples for the samples, samples of the previous exams, and also I uploaded the previous lectures of the previous semester, if you need to check. And I finished now. Maybe also I have extra problems, but the time is up, so I'm sorry, I have to stop here. Do you have any question? If you don't have any question, so we can meet at 1 o'clock if you need to do the worksheet together.
Doctor,
Doctor,
Yes.
So the white curve, the 0, 1 curve.
The white curve, the white one, yes.
Wouldn't it intersect with other curves? Considering
No,
that
can't at all intersect with any other curve.
I mean, the curve is asymptotic to the c equals 0, but other points along the c equals 1, so like 1, 1, 2, 1, 3, 1 would also be asymptotic. So they all go the same direction. Wouldn't they just intersect them?
Just a minute. You asking me about this white, and you said that when c equals 0, the curve this one, which has an equation y equal to, is asymptote to my solution. Okay? Yeah. Now, what about of C1? You said C1?
Can I annotate? Just show what I mean.
Yes, you can. Yes, Abdurrahman, I will help you. I will answer your question.
So can. Like this would also go like this, and so on.
Yeah, but yes, you are. Look, yes, I understand you. But now I need the solution go from the point 0, 1. But this one, which you drawn here, is go from the point 1, 1. You are right. If I asked you to draw the curve which go from point 1, 1, not 0, 1, 1, 1, so it will be like this. You are right.
Yes, I mean they will intersect like 1, 1 and 0, 1.
No. This one, look, this is the solution. This is the solution, the first one. This is the first one. And this is the second. If you need to the point 1, 1, it will be like this. They can't cross each other. Those are asymptote to each other.
Yeah, they're also asymptotes to each other. So the asymptotes to c equal -1, and the asymptotes to each other.
Yes.
Yes.
But by the way, usually I will give you numbers such that the curve of each one is far away from the others. Okay?
Yeah, okay. Thank you a lot.
Yes,
Doctor, if I draw, يعني if I get a C مثلا equals to 0.5, I will have another line between C equals 0 and C equals 1, so the white line might intersect.
Might intersect what? You are right, but you have to tell me the white color or white curve might intersect what?
The slope fields.
And the isocline. Let me say the isocline. No problem if my solution cross the isocline, but there is a problem if my curve cross the slope field. Let me choose the C equal half and check together if the C is half. You can, so by the way, at that time your slope, it will be half, okay? And here maybe you will have the curve here. Sorry, you have the isocline. I'm sorry. So the new isocline, it will be here. On it, maybe the slope will be like this. So also it's a tangent. So you have more than one tangent. Okay, did you get the idea? So let me consider I have here isocline. Okay, at that time, your solution must with the following slope field must be like this. So the white is tangent to the blue. Okay, so if you choose more C's, your curve will be more accurate. So you have more tangents. Okay, but sometimes if your scale is small, so you can't understand the crop at that time.
Okay, thank you, Doctor.
Welcome.
Doctor,
Yes.
Is it possible to make the return a little bit after 8:30 for people who don't live in Cairo?
Actually, because we arranged and we reserved the room for the exam. So where do you live?
I live in Suez.
Let me stop the record now. So I finished the lecture. If you need, you need